Hello, my friends. Welcome to this discussion. We are going to go through a journey of probability, and we're going to understand using a quiz. And then make sure that in this discussion, be having a pen, a paper, and a calculator so that you are able to do this on a side. And also be free to pause and first pick the question, think about it, and write the answer. Then look at the answers that I have provided and the explanation. Let's go. If a fair die is rolled, what is the probability of getting a number greater than 4? So have A, 1 over 2, B, a third, C, a sixth, D, 2/3. If a fair die is rolled, what is the probability of getting a number greater than 4? Let's go. The answer is a third. Explanation is that numbers greater than 4 on a die are 5 and 6. So the outcomes being 6, the favorable outcomes being 2, the probability would be 1 out of 3 coming from 12 out of 6. Yes. Question 2. A bag contained 3 red balls and two blue balls. If one ball is drawn at random, what is the probability that it is red? As 1 over 2, 2 out of 5, 3 out of 5, and 4 out of 5. So what is the probability that is going to be red? So the answer is going to be, we have total balls being 5, and we have 3 red balls. So the probability will be red out of the total sample space, and this would give you 3 out of 5. What is the probability of drawing a king from a stand deck of 52 cards? If we're having a stand deck of 52 cards, what is the probability of drawing a king? Yes. So we have 1 out of 13, 1 out of 26, 1 out of 52, and 4 out of 13. So what is the answer? The answer is 1 out of 13. The explanation is that there are 4 kings in a deck of 52 cards. The probability would be 4 out of 52, giving you 1 out of 13. Yes. If 2 coins are flipped, what is the probability of getting at least 1 head? A, we have 1 out of 4, B, 1 out of 2, 3 out of 4, and D, 1. If 2 coins are flipped, what is the probability of getting at least 1 head? So, let's see the answer. 3 out of 4. Explanation is that the outcomes with at least 1 head, you have head, tail, tail, head, and those are 4. So total outcomes are equal to 4, and then we're talking about how many are having a head. So 1, 2, 3. So 3 out of 4 would be the probability of you having a head. In a class of 20 students, 12 are girls. If a student is selected randomly, what is the probability that they are a boy? So A is 2 out of 5, B 3 out of 5, 3 out of 10, and D 4 out of 5. So in a class of 20 students, if you have 12 being girls, and that means the rest are boys. If a student is selected, what is the probability that the person or the student you've chosen is a boy? So this is going to be 2 out of 5. You have total students being 20, and you have boys being 8. So 8 out of 20 to give you A, which is 2 out of 5. Yes. So let's look at conditional probability. If a card is drawn from a deck, what is the probability? It is a queen, given that it is a face card. It is a face card. So let's see. A, 1 out of 13. B, 1 out of 3. C, 1 out of 4. And D, 1 out of 12. Yes, there is conditional probability. So let's look at the answer. So the answer is 1 out of 3, which is B. First cards, we're talking about they are 12. So for each of Jack, then we have a queen, we have a king. So we have 4 queens, and the probability that it is a queen is going to be 4 out of 12, because the sample space here, the first cards are 4 times 3, which is 12, and the queens are 4. So that would give you 1 out of 3. Good. A box contains 6 black balls and 4 white balls. If a black ball is removed and not replaced, what is the probability of drawing another black ball? A, 5 out of 9, B, 1 out of 2, C is 5 out of 10, and D is 6 out of 10. Yes, so the answer is A, 5 out of 9, and the explanation is that after we have removed 1 black ball, the remaining black balls become 5. So the total balls are 9. So the probability of getting a black ball is going to be 5 out of 9. Yes, that is if you pick without repressing. Now, next question. What is the probability of getting a 4 on a die roll, given that the outcome is an even number? So A, we have 1 out of 6, B, 1 out of 3, and C, 1 out of 2, and D, 1 out of 4. So this is conditional probability. We're talking about getting a 4 on a die roll, given that the outcome is an even number. So you have a die, and 1, 2, 3, 4, 5, 6. So which of those is an even number? So let's go. 1 out of 3. So we have 2. We have even numbers 2, 4, 6, and the favorable outcome being 4. So the probability would be, so the sample space is 3 when we talk about even numbers, and if the favorable outcome is a 4, then the probability of getting an even number is going to be a third. Wonderful. Question. We are talking about now independent and dependent events. So 2 dice are rolled. What is the probability that both show a 6? So A is 1 out of 36, B 1 out of 6, C 1 out of 18, D 1 out of 12. Yes, so 2 dice are rolled, and what is the probability that both will show a 6? So the answer is 1 out of 36, because the probability for 6 on one die is 1 out of 6, and for both, that is A intersection B. So where you have a probability of A times probability of B. So you have 1 out of 36. If 2 cards are drawn from a deck without replacement, what is the probability both are S's? So what would be the answer? 1 out of 221, 1 out of 169, 1 out of 52, and 1 out of 13. So the answer is 1 out of 221, because the probability of the first S is 4 out of 52, the second 3 out of 51, and when you combine the two, we'll have 4 out of 52 times 3 out of 51, giving us 1 out of 221. That is wonderful. So you can do more research about the numbers or the naming of those cards in a 52 pack. Yes. So what is the probability of drawing either a king or a queen from a deck of cards? So A is 2 out of 13, B is 1 out of 13, C is 1 out of 26, and D is 4 out of 13. So what is going to be the answer? Here we're talking about mutually exclusive and complementary events. So this is an example of a question that can come under mutually exclusive and complementary events. Okay, so the answer is 2 out of 13, and the explanation is that the probability of a king is always 4 out of 52, that is 1 out of 13. The probability of the queen is 1 out of 13, and if we combined them together, we would just add the 2, and therefore would have 2 out of 13. That is wonderful. Let's see the next. The probability of an event A occurring is 0.7. What is the probability of its complement? So if you have a probability A and is 0.7, then its complement would be, okay, so A is 0.3, B 0.5, C 0.7, and D is 1. So the answer is, yes, you guessed it right, A, which is 0.3. The complementary probability will always be 1 minus 0. That probability. For example, probability of A complement would always be 1 minus probability of A. So which is giving us 1 minus 0.7, giving us 0.3. Two events A and B are mutually exclusive. If probability of A is equal to 0.4 and probability, we said probability of A is equal to 0.4 and probability of B is equal to 0.3, what is the probability of A union B? So we are talking about part A, 0.4, 0.3, 0.7, and 1. So what is the answer? Okay, so we find that if we are talking about mutually exclusive events, we mean no overlap. So probability of A union B would eventually equal to probability of A plus probability of B. And this would be 0.4 plus 0.3, giving you 0.7, which is C. So that is mutually exclusive events. So let's look at probability distributions. So here we are given this question. For a fair coin flipped 3 times, what is the probability of getting exactly 2 heads? We are talking about A, 1 out of 8, B, 3 out of 8, C, 3 out of 4, and D, 1 out of 2. So what is the answer to this problem? So answer is B, because the total outcomes, we are talking about 8. We have head, head, tail, head, 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 tail, head, tail, head, head. And the probability would obviously be how many tails are we talking about? There are 3. So 3 out of 8. Okay? Yes. So let's proceed. A fair 6-sided die is rolled. What is the expected value of the outcome? So if a fair 6-sided die is rolled, what is the expected value of the outcome? So we're talking about 3, 3.5, 4, and 4.5. Yes. So the answer is 4.5 because the expected value would be sum of all outcomes, which is 1, 2, 3, 4, 5, 6. Then we divide it by the total number of outcomes, which is 6. And this is giving us 3.5, which is B. That is how we get the expected value in such a scenario. So we are still continuing. In a probability distribution, the sum of all probabilities is always 0, 1, less than 1, and greater than 1. What is the answer? So it is B, which is 1. By definition, the sum of all probabilities in any distribution is always 1. So let's look at theoretical and experimental probability. If a die is rolled 60 times and the number 4 appears 15 times, what is the experimental probability of rolling a 4? So we have 1 out of 6, 1 out of 4, 1 out of 3, and 1 out of 5. So the answer would be experimental probability is the number of favorable outcomes divided by the number of trials. So the favorable outcomes, as we have seen, we are looking at 4 appearing 15 times. And so if we are rolling it 60 times, then the experimental probability is going to be B, which is a quarter. Yes. So theoretical probability assumes that A, all outcomes are equally likely. B, the experiment is repeated many times. C, biases exist in the outcomes. And D, only one trial is conducted. Theoretical probability assumes that. So all outcomes are equally likely, and the explanation is that theoretical probability assumes that all outcomes have the same likelihood. So that is theoretical probability. All outcomes are equally likely. So that is A. So let's look at advanced probability concepts. So if probability of A intersection B is equal to 0.2 and probability of B is equal to 0.5, what is the probability of A given B? Is it 0.1? Is it 0.2? Is it 0.4? Is it 0.5? Let's see. So the answer is C, because conditional probability of A given B is probability of A intersection B divided by probability of B, which would give us 0.2 out of 0.5, giving us 0.4. Pina is divided into 5 equal sections labeled 1 to 5. If it is spanned twice, what is the probability of the sum of the results being 7? A spinner is divided into 5 equal sections labeled 1 to 5. If it is spanned twice, what is the probability of the sum of the results being 7? So A is 1 out of 25, B 2 out of 25, C 4 out of 25, D 6 out of 25. Answer is 2 out of 25, because the favorable outcomes for the sum, you are having 2 and 5, 3 and 4, 4 and 3, 5 and 2. So these are how many outcomes? 1, 2, 3, 4. And divided by the sample space, we're talking about 25. So the probability would be for out of 5, so which is C, not B. So this would give you C, not B. Okay, how many ways can 4 people be seated in a row? So we're talking about permutations and combinations. So if you have 4 people, how can they be seated in a row? So this is going to be a permutation. And this is A, 12, B, 24, C, 4, 16, D is 4. Let's look at the answer. So this is a permutation problem because the order of seating matters. For n terms arranged in a specific order, the total permutations are calculated as permutation of n is equal to n factorial. So for 4 people, this is going to be 4 factorial, giving us 24, and therefore there are 24 ways to arrange 4 people in a row. Yes. From a group of 6 people, how many ways can you select 3 people? So A is 20, B is 120, C is 18, D is 50. So this is a combination problem since selection does not depend on the order of the people chosen. The formula for combination, therefore, is any combination R, which is n factorial divided by R factorial into n minus 1 minus R factorial. So n is equal to 6, and we are talking about 3. Okay, 3 ways. Okay, I mean, we are looking at 6 people and we are selecting 3 people. So this is going to be 6 selecting from 3, and this is going to give us 15 ways. So there are 15 ways to choose people from a group of 6 based on this calculation. How many permutations can be made from the letters in a word book? So this has a double letter. So let's see. A is 24, B is 12, C is 120, and D is 36. Okay, so let's see. The word book has 4 letters, but 4 repeats twice. So to account for repetitions, the total permutations are calculated as, permutation would be now the total number n divided, of course, factorial divided by r factorial, whereby this r1 represents the two letters that are double or that are repeated. So the permutations would be 4 factorial divided by 2 factorial, giving us 24. There are therefore 24 unique arrangements of the letters in the book. How many ways can 5 students be arranged in a circle? So A is 120, B is 24, C is 60, and D is 12. Yes, the answer would be 6. And for such arrangements, the number of permutations is n minus 1 factorial. N minus 1 factorial. So this is because one position is fixed as a reference, reducing the total permutations by 1 factor. For 5 students, we do have 4 factorial, giving us 24. And therefore, there are 60 ways to arrange 5 students in a circle. Yes, sorry, this is supposed to be 24 ways, not 60. So it should be 24 ways to arrange the 5 students in a circle. So you should recorrect this. So remember, it is 5 minus 1, okay, factorial, giving us 24. From a deck of 52 cards, how many ways can you choose 5 cards? So we have 2, 5, 9, 8, 9, 6, 3, 12, 0, 0, 100,000, and 25,000. So we are having 52 and we are choosing 5. So this is going to be a combination problem, and therefore when we use that, okay, we shall find that this is going to be 259,896 ways to choose the 5 cards out of 52. How many ways can 3 boys and 3 girls be arranged in a line if the boys and girls must alternate? Is it 36, 72, 120, and 720? Okay, so we are talking about arranging the boys separately. So we have, first of all, 6 ways to arrange the 3 boys, and 6 ways to arrange the girls. So since the arrangement must alternate, starting with either a boy or a girl, there are 2 patterns. So this could be boy, girl, boy, or girl, boy, girl. Thus, this is going to be 6 by 6 by 2, giving us 72 alternating arrangements. In how many ways can you arrange the letters of the word committee if the E's are indistinguishable? So we have 5,400, 45,360, 40,320, and 30,240. Yes. So this is a problem to deal with the permutations. So we have how many? We have M repeated, T repeated, and E repeated. So if we are talking about 9, so we shall have 9 divided by R1, which is for M, R2, which is for T, and R3 for E. So those that are repeated are the ones represented by their numbers. So this is going to be 45360, and those are going to be the unique arrangements that are needed in this problem. How many 3-digit numbers can be formed using the digits 1, 2, 3, 4, and 5 without repetition? If there is no repetition, then okay, so let's see. A60, B120, C24, D 10. So think, pause, think about it the more, and give me the answer. So this is going to be 120, and I mean, if, for example, we are talking about the permutations, and we have the order mattering. So you are going to have 5 factorial. Remember, we have 5, and we are talking about choosing 3. Okay? We have how many? 1, 2, 3, 4, 5. And we are choosing 3. So this is going to be a permutation problem if we are not to have any repetition. So this is going to be 60. So this is supposed to be A. Thus, there are 60 arrangements, okay, that we can use. So let's move. So correct this. This is supposed to be 60, not B. Okay. How many ways can a president, vice president, and secretary be chosen from a group of 8 people? So remember, since you can only have 1 president, you can have 1 vice president and 1 secretary. So you are going to consider using permutations. So this is 56, that is A, 336, 120, and 720. So let's look at this. This is a permutation problem. The order of the rows matters, and therefore we have 8. We are picking 3 people from 8 and no repetition. So this is going to give us 336 ways to assign the rows. From a group of 10 items, how many ways can you choose for items? So we have 210, then we have 120, then 252, D 360. Yes, from a group of 10 items, how many ways can you choose for items? Yes, so let's see. So this is a combination problem. We are having 10, we are choosing only 4. So we are getting to 52 ways to choose 4 items from 10, and this gives us C as the correct answer. So ladies and gentlemen, this marks the end of our discussion. Please like this, and remember to hit subscribe button. Make sure that you go through this over and over and over again, memorize and understand these basics of probability. Thank you.